Okay, so what I have here is a Fluke 8060A multimeter. This is one of my first multimeters way back. It's been sitting on my bench recently since I'm having issues with it, and since I have a newer multimeter, it's Fluke 175. Okay, so let me just show you what issues does this meter have right now. So as you power this up, it shows a weird display like that, and then sometimes it will react to the probe input, sometimes it will not. Let me just test it right now. So you see it's reacting right now. We can measure some resistance. For example, I have here a 15 ohm resistor. Okay, so right now it's not reading anything. Okay, let me try this. As I've said, these faults are really intermittent, so as I power this on, displays characters like that, and then it goes to standby mode, and now you see it's gone. So let me try that one more time. Okay, so again, weird looking displays like initializing or something, and then okay, so it's reacting right now. Let's measure some resistance again. Let's try. Okay, so this is a 15 ohm resistor, and I hope you can see that it's actually like 18 or something. Okay, so I don't know if it's calibration or just the issue itself, but like that. I searched online and found someone who's able to fix similar issues on this meter, and I'll just post a link to his website just to get credit to him. And I was able to download a service manual for this, so I thought I had a try and fix this. So the next shot, I will open this up, have a look inside, and maybe do some tests. And I've had this with right now it's on a new 9-volt battery, so I think it's not power issues, or as I've said, it's just barely intermittent. So right now it's reacting again, so let's try these buttons. These are sometimes working, sometimes not. So you see it's working right now with the buzzer and all. Okay, let's try that. See, it's just sometimes it works, sometimes it's not. So I will open this up, try some tests based on the manual, and let's see. Okay, so I was able to open this up, and this meter is really crusty right now. As you can see, as I took just 3 screws on the back, so as I took the screws off, some plastic parts just, you know, fell off the case like that. Okay, this screw terminal is cracked already, and I just have to really take care in further disassembling this if ever I need to. But also, as I'm removing this LCD assembly here, like that, okay, some screw terminals just, you know, just fell off. So I hope I can fix that later on. But looking at the electronic parts, looking on the inside, there's really seems good. Okay, there's the input protection circuits right here, and then there's the Fluke 8060 right there, and some calibration procedures and some test points, you know, like that. Anyway, so to the next step, we'll be verifying some readings on the test points and the manual. Service manual provides some info on that. Sorry for the crappy camera here, but these are the service manual indicating the some test points and readings. Okay, so we'll go ahead and do that, but before we can do that, I think I may have to do some modification on this LCD assembly, because this LCD assembly is connected to the main board, okay, by this conductive flexible plastic right here. These are really parts of when you see an LCD display like that, it usually is connected to the main board by a flexible plastic, conductive plastic like that. So right there on the bottom of the LCD, you can just see another one right there. Okay, so what I'm thinking is, because some test points are located here and we cannot verify those test points unless this assembly is connected to the main board, so what I'm thinking is just maybe soldering a ribbon cable here directly on the LCD board. If you remove this plastic right here, there's just traces there where I can connect a ribbon cable and proceed with verifying those test points. So I'll just do some soldering and then we'll come back to verify those test points. Okay, so I went ahead and did the modification for this flexible connector, which connects the LCD assembly to the main board. And what I did is just solder 13 pairs of wire from the main board to the PCB assembly, and I think this might be a permanent fix for this mirror. We have to do this because this is held in place actually when you put the case all back together, and we cannot really do that since we have to access those test points for this step. So let's just power it on, and so you can see it's the same issue right here. It displays random characters on startup, and then seems to go on a standby mode. Okay, so let's just verify those test points. First, it's test point number 1. From this diagram, it's not really shown where TP1 is. Okay, but looking at the schematic, I determined that test point 1 is right here. This is actually a regulator circuit which regulates the 9-volt supply into a 5-volt supply using a transistor right there, and TP1 right there is connected directly on the source of that transistor. That transistor is right here. Okay, hope you can see that, just beneath the just beside the buzzer under this LCD assembly. So let me just probe that to verify, and there we go. There, it's a stable as expected. It's a stable 5.2 supply. Okay, test point number 2 should be the negative supply. Okay, Okay, test point 2 here is indicated to be on the wiper part of switch number 2, and this should be right here. Okay, so test point number 2 seems a little bit off. It's just 4.9. It seems to be unstable. Okay, so supposed to be negative 5.1. It's not really stable right now. Okay, so again, we'll take note of that. Next is test point number 3. Again, this diagram does not indicate this indicates that TP3 is under the board, but we can't really flip the board. So but test point 3, we can look at this. It's just the same as test point number 8. Okay, so test point number 3 is the 3.15 reference. Okay, perhaps for this LCD assembly, and test point number 8 is the same 3.15 volt reference for this main board. So test point number 8 is right here in the middle, so that you can just verify that. So that's expected to be around 3.15 volts, but we're really getting only 2.05. okay, so again, that may be an issue, and we'll just verify that later on. So test point number 4 is right here. Just point that. Okay, just beside those two trimmers. Okay, but I can't really poke into that directly because it's coated with some varnish or something. But looking at the diagram again, test point number 4 is right here, which is directly on the pin 5 of this component Z5. So you can just, this is that component Z5, so you can just probe at pin number 5 of that. So let me just probe that. 1, 2, 3, 4, right here. Okay, so it's expected to be 1, 2, 3, 4, 5 volts, but it's close. It's 1.229 volts. Okay, let's just take note of that, and maybe we can look at it later. Next, test point number 5 is just ground. Test point number 6 is it's just a trigger for the analog to digital converter. Okay, test point number 7 should be also a positive 5.2 volts. Okay, the one we measured is on this main board, while test point 7 here is on this LCD assembly. So just verify that. Again, it's the same. It's a stable 5.2 volts. Test point number 8, we verified that earlier. It's the same as test point number 3. Okay, for test point number 9, you just quickly look at the scope, since this is 40 kilohertz clock. Okay, so let me just set the scope here, and let me just probe that. So test point number 9 is right here in the LCD assembly, and there you go. There's test point number 9, and I hope you can see that, but the reading is bang on. It's 40 kilohertz. Okay, so for the other test points, there's not much indicated here. It's just test point number 10 and 11 is just a comparator output. Maybe I can just verify that on the rest of the manual. But right now, what's really interesting to look at is the readings we have on test point number 2, which is supposed to be at negative 5.1, but really reading around 4.9 and it's a bit unstable. Also at test point number 3, which is supposed to be at 3.15 volts, but we're only just getting 2 volts, and that's really interesting to look at right now. So looking at the diagram, test point number 3, right here, we can see that it's also coming from the stable 5.2 supplies, just like coming from a voltage divider. Okay, and then but we can see that there's a capacitor here, and these meters are known to have a reputation on having bad caps. Well, that's understandable because these meters are produced maybe early 80s, so capacitors over time, especially electrolytics, they tend to go bad or leaky. So it's interesting to know, maybe that's why this voltage is quite low. Maybe the capacitor is leaking already and it's pulling those voltage divider down. So that's why instead of 3.1 volts, it's down to 2 volts. Okay, we'll take a look at that capacitor, and it's C12. Also, for the other one at test point number 2, this is our negative supply. Looking at the diagram right here, that's the negative supply generator, and test point 2 is right here. So test point number 2, again, immediately on the output here, you can see another electrolytic cap. Okay, since we already have a negative voltage, we can maybe conclude that this IC is still working because it's generating a negative voltage. Okay, this was out, maybe a negative voltage will not be even generated on that, but it's just interesting to look also on this cap. Maybe again this cap is leaky and it's just pulling the supply down. Okay, so I'll just take a look at those components, test it out, and we'll see what we can do next. So after about a couple of hours, I was able to pull out and test all the components of interest right here, particularly those around test points 2 right here and test points 3 right here. All these components, these green ones you see here, they were all pulled out of the circuit and tested, and they turned out to be good. So I just put them all back, and then but this guy right here, that capacitor across test point number 3, seems to be a bit out of spec, so I just replaced it. This is the guy right here. It's 10 microfarad cap, and it's just below that LCD assembly right there. Okay, so it's connected across the voltage divider here at test point 3, which initially we had a reading of around 2 volts where it's supposed to be around 3 volts. So after replacing that, we're seemingly back on spec. Let me just test this capacitor again. Okay, so we go to capacitance, and then we just hook this up right here, and so it's around only 8 microfarad, so I just replaced that with an old part, another part from my components bin, and seems to do the job. Okay, so let's just power this on, but before that, I just would like to mention again another test point of interest. That's test point number 2. Initially we're reading around 4.9 volts right there, and I did just notice this on the calibration shield right here, that test point number 2 can be plus or minus 0.2 volts. Okay, so reading this at 4.9 volts, it seemed to be okay within specification. So I just put the components back. After all, they all are within spec. Now those are, I think, 100 microfarad caps, and they all they're all still good. So let's just turn this on there. So right now the display is looking good. Seems to be working well. The display is complete. No weird display or missing characters right now. And I forgot, initially I didn't mention it before, but it may seem obvious that the LCD have problems as well. Well, I didn't pay much attention to the LCD at first because I'm observing abnormal voltage readings around here, so there's no use in fixing the LCD if ever, when I have other concerns in the circuit. But then after fixing those bad caps, I just cleaned the LCD assembly and then put it all back together. I just secure it with you can see that this LCD assemblies are so sensitive. Okay, if you're not careful, you can actually damage them, break the glass, or damage those conductive plastic connecting the actual LCD to the board. So I just carefully cleaned that out, put it all back together, and luckily it works fine. Okay, so to verify the improvements here, let's just quickly measure the 2 points of interest we're previously concerned. So I'll just hook up the meter here. Okay, we go to the voltage, and then this is TP3. TP3, remember, is the same as test point number 8 right here. So right now it's at 3.3 volts. So that's an improvement far from the previous reading we had, which is around 2 volts only. Okay, and then for the test point number 5, it stayed the same there, so it's around 5.2 volts. Okay, so there's really an improvement right there. So all's working good now. The readings are well within spec, and this is starting up properly. No more garbled display or weird looking characters, as you can see. So I'll just assemble this. I'll just put it all back together with this front panel and the shielding and all, and we'll do some additional tests according to the service manual, and then we'll do some measurements. Okay, so for the final part of this repair, we'll just perform some diagnostic self-tests here in the manual. So for the first test, this is the ratio self-tests. It says here that if the instrument is functioning properly, the display should read at 10,000 plus minus 10 counts. Okay, so let's just do that. It's simple. Just power off the unit, then you press this continuity button here while powering it on. Okay, then it should display 4/8 with decimals. There you go. Then should display the count. Okay, so the decimal point just really depends on where the range is, like that. Okay, so right now it's looking good. It's just off by 2 counts, so this confirms the meter is working or have some functionality after all. Okay, so for the next test, that will be the switch decoding self tests. So this is performed like this. Here we have a table, and then the display should correspond with the meter settings or which button is pressed. Okay, so let's just initiate that. To do that, you just press this relative or rel button while powering up the unit. Same happens. It should display 4/8 with decimals, then you release. Okay, so for this test, each digit corresponds to a button. Like for this digit, the second one, okay, this corresponds to these 4 buttons right here, depending on what is pressed. Like if you press this button, this should display 8 right here. Okay, so it's the second part of the button. Okay, this is 8, 4, 2, 1, and then if none is pressed, that's 0. So that's working fine. For the range, it's this digit right here, the last one. So for 200 microamps, that's 0 right there, and it goes on progressively as you go up the range to 1, 2, 3, and 4. Let's try that. 0, 1, 2, 3, and 4. So all these buttons are working. Next, we have the function buttons. Okay, so this is the last digit right here. Okay, let's try that. To display that goes from 1 to 7 right there. So to display number 1, we set it to AC voltage, like this. There, that's 1. For 2, that's DC voltage, that's number 2. For number 3, that's AC current. So current is like this. Okay, and then DC current is number 4 there. For number 5, it's resistance, like this. For number 6, it's conductance. Conductance is this. This is S. It's not at first I thought it was a unit of time like nanosecond or something. That's actually Siemens. It's the unit of conductance. So to set for conductance is like this. Okay, that's number 6. And for the number 7, that's diode test, like this. There you go. So basically what this tells us is the functionality of the unit in terms of the buttons right here and the function buttons right here. They're all working fine. So for the next step, let's just reset the meter. For the next test, let's do some voltage, current, and the resistance measurement. I have here my power supply right now. I hope you can see that it's set at 5 volts at 1 amp current limit. So let's just enable the output, and let's put this first to voltage. So voltage setting is like this, like so, and then since we are at 5 volts, we'll put this at the 20 volt range. Okay, so let's just measure this out. The camera is on the way here, so Sorry, I have to enable this one. There you go. And that's 5 volts right there. To compare, just to compare the reading with my other meter, let's just verify this one. And that's, oh, it's much closer as expected. That's 4 point, hope you can see that. That's 4.99 volts right there. Okay, so this meter seems to be working fine, measuring voltages. Let's go to a lower range like 1 volt. Let me just adjust the power supply to 1 volt. Okay, and then let's change the range to 1 volt. Go, and 1 volt it is. Okay, so now let's just measure some currents. Okay, so let's just reconfigure the leads here for current measurement, and then configure the buttons like this one for the current measurement. And my power supply right now is set at, I think, 1 amp. So let's just try it out. So let's just select the 2 amp range. Okay, and let's try this out. Okay, so that's 1000 milliamp right there, or 1 amp, and you can see that the power supply is current limiting to 1 amp. Okay, so that's working fine. Maybe we can go on a lower range. Let me set this to around 10 milliamps right there. Okay, so let me just change this to 20 milliamps. Okay, so it should read about 10 milliamps right here. Let me just set the meter again. Oh, I should use this fine adjustment button. That's actually 100 milliamps, so right there. So that's 10 milliamps. Should see that. And there you go. It's not that accurate at lower ranges, but I don't intend of using this for precise measurements, just for quick measurements of voltages and resistance. So I think it's gonna do fine. Also, I didn't recalibrate this thing, but that's the easy part. I just have to read the whole service manual for this on how to properly calibrate this one. I didn't really bother to calibrate this right now. Maybe in the future video I'll show how to properly calibrate this meter. Okay, so for some, let's just try out some resistance right here. So again, we configure the leads here for resistance measurement like so. Then we go for resistance like this. For the initial test, I have here a 15 ohm resistor. So let's just go within range. There you go. It's 200 ohms, and let's just measure this out. And there you go. 15 point, almost 16 ohms. It's okay. And then I have here like I think this is a 616K. So let's just go within that range all the way to a mega ohm and measure this out. Okay, so that's 614 kilo ohms right there. So it's doing good. For diode testing, let's just try some LED here. So here's the diode test. Just do it like that. Then we go to the diode test, which is configured as is. Then we'll test some diodes, which is an LED. Okay, so I hope you can see that the LED lights and the meter is indicating a reading. So let's reverse that. Should not. Okay, so that's I think that's working fine right now. What else? Other notes, what I did to this meter. On verifying, after replacing the capacitors back, I verified the voltage without the ASIC, the big IC you see there, just behind the LCD. I lifted the ASIC of the socket and then measured the voltages. The voltages actually went up a little bit. So the 5-volt rail went up to around 6 volts, and the 3-volt rail went up to about 5 volts. So first, I suspect that the ASIC may be damaged because it's pulling the voltage so low. But then I really had no choice at this point, so I just put back the ASIC and then verified the voltages as is. Okay, so that's it for this repair and a little modification. I can use this meter right now. I'll read the manual on how to properly calibrate this. Maybe it requires a function generator or something, a signal generator, or maybe a small signal source. So I have to find a way to provide that in order to calibrate this properly. So that's it. Hope you learned something, and I enjoyed repairing this unit. Now I have another unit on my stash. So